Today we will see Rutherford's model of an atom. So far we have seen about the J. Thomson's model, who told and compared the model from the watermelon or from a plum pudding model. Now there was scientist Rutherford who performed an alpha scattering experiment. Actually there were two research scholars of Rutherford named as Marsden and Giger. These two performed the experiment and Rutherford gave the conclusion of the experiment. Now what is this? First of all you have to see what is the experiment they proposed. For this experiment, the alpha particles emitted from a radioactive element such as polonium were allowed to strike thin sheets of metal such as gold and platinum. Now question arises, why they take only gold for this experiment? So answer is, you know that gold is a very malleable metal and we can form a very thin sheet of gold. Now motto is to prepare a single layer of atom as good possible as. So gold was best. That's why gold was used in this experiment. Now a beam of alpha particles was obtained by placing polonium in lead box and letting the alpha particles come out through a pinhole from the lead box. So for experimental setup we required alpha particle source. Second we required gold foil, and third we required lead box. Now here you can see the real experiment which was performed by Giger and Martin. Here you can see this is the lead box in which alpha particle source is put, which may be a polonium or radium also. Now the alpha particles emitted from this directly collide to the thin sheet of gold foil. Now after collision, what were the observation? You can see here there were scintillation to detect all the collisions and all the deflections, followed by the baking of alpha particles. Now here you can see in the inside the alpha particles which directly collides to nucleus, and some of the rays are directly passed, some are diverted, and one ray come back at 180 degrees centigrade. Now this beam of alpha rays were directed against a thin gold foil which is approx 0.004 centimeter thick. Now you can guess how much thickness of this gold foil is. That's why gold is used for scattering. A circular screen coated with zinc sulfide was placed on the other side of foil. To a zinc sulfide layer was put. Why this is so? You can see here, when the rays strike to zinc sulfide layer, there will be fluorescence, and due to fluorescence we can analyze that on this place rays are colliding. So you can analyze the angle from which they are diverted. Now about 99% of alpha particles passed undeflected through gold foil and caused illumination on zinc sulfide screen. Here you can see this is gold foil, and from this gold foil the 99% of particles were deflected like this, and they are struck directly to a sulfide screen and give rise to illumination. A very few alpha particles underwent small and large deflection after passing through the gold foil. Here you can see there are some deflection at some angles like that. So ratio of number of these rays were very low, and a very few, 1 in 20,000, were deflected backward on their path at an angle of 180 degrees centigrade. You can see this ray again comes to at 180 degree like that, and this is only number 1 in 20,000. So here we can see observations. What are the observations of Rutherford's model? Number 1, since a large number of alpha particles passed through the atom deflected Hence there must be a large empty space within the atom. Here you can see the ray A, this A are passed through. You can see a structure of atom. Suppose this is a nucleus and there is the shell in which electrons are moving. And you can see there, if you compare the volume of this nucleus to volume of except the nucleus of atom, we can see easily that the volume of nucleus is very less as compared to volume of atom. So most of the space of atom is empty. That's why the 99% of alpha particles pass through the atom undeflected. Hence there must be a large empty space within the atom. So we can see here large number of alpha particles pass through the atom undeflected. Hence there must be large empty space within the atom. Now the second observation we can see here, you can see the ray B is deflected somewhat from the path. So there is some angle between that. So why this is so? You can see here there are some deflection about an angle. So as some of the alpha particles of gold deflected, therefore there must be something massive and positively charged structure present in the atom. The second observation is that some of the alpha particles are deflected because there is something massive and positively charged structure present in atom. Here you can see there are two terms. First one, something massive. The main mass of atom is due to only nucleus. So if alpha particles to be scattered from their path, there should be a great opposition from the nucleus, and this can be achieved by only if nucleus should be more massive and it have positive charge, because alpha particles are nothing but helium plus 2 ions. They have no electrons, so total alpha particles are positively charged. So when this comes to this path, they will repelled by nucleus and their path will be deflected only if nucleus is heavy. If you are take lighter atoms, then it may be possible that this phenomena will not take place and you will not observe that nucleus is massive or not. That's why this is another reason that we have taken a gold foil, because gold is also a heavy metal. Now third observation of Rutherford experiment was that the number of alpha particles which got deflected is very small, therefore the whole positive charge in the atom is concentrated in very small space. Here you can see one rays out of 20,000 get deflected through 180-degree angle. So you can see here it collide with the nucleus and repelled by at 180 centigrade. Why this is so? So we can analyze easily that the mass of atom is totally centralized in the nucleus and positive charge is also centralized in the nucleus, and that tends to move the particles in 180 centigrade. So here we can see the number of alpha particles which got deflected is very small, therefore the whole positive charge in the atom is concentrated in very small space, that is nucleus. Now the fourth observation was that some of the alpha particles retracted their path, that is came almost straight back toward the source as a result of their direct collision with the heavy mass that we have seen. Now the alpha particles are made up of 2 protons and 2 neutrons and are helium nuclei. What are the alpha particles? If you take the helium, we can know helium is 2He4, means there are 2 electrons, 2 protons and 2 neutrons. Now we want to convert in alpha particles to remove the 2 electrons of helium atom, then we get He plus 2. Now situation comes, electrons are 0, protons are 2 and neutrons are 2. So totally this is positively charged particle. The positive charge heavy mass which occupies only a small space as compared to the total space occupied by atom is known as nucleus. Now Rutherford proposed a new picture of structure of the atom somewhat bigger than J.J. Thomson model. Because J.J. Thomson model was totally based on assumption, there was no experiment like that Rutherford. And Rutherford gave a real picture of atom which is true today. Main feature of this model are, first one, the atom of an element consists of small positively charged nucleus which is situated at the center of atom and which carries almost the entire mass of the atom. So we can see the nucleus is present in the center of atom, contains positive charge, and this is massive part of an atom. Second one is that the electrons are distributed in the empty space of the atom around the nucleus in different concentric circular path. Here we can also write down it. Electrons are distributed in empty space of the atom around the nucleus. Third one is there, the total number of electrons in the orbital is equal to total number of proton in the nucleus. Total number of electron is equal to total number of proton in a neutral atom. Fourth observation is that the volume of nucleus is very small as compared to the volume of atom. Volume of nucleus is very small as compared to volume of atom. The most of the space of atom is empty, and this space electrons are revolving around nucleus. Now the question arises about stability of this type of system. The stability of such a system in which negatively charged electrons surround a positive charged nucleus was explained by proposing that electrons revolve around nucleus at a very high speed in circular orbits. This arrangement is just like our solar system. The high speed of moving electrons give them a centrifugal force acting away from the nucleus. The centrifugal force balances the electrostatic force of attraction acting between the nucleus and electrons. This was about the stability of this type of system of atomic structure. Now there are some defects in the Rutherford model we can discuss here. Defects of Rutherford model. First one is that Rutherford did not specify the number of electrons in each orbit. He did not tell about number of electrons. Second one, the main big mistake is that according to electromagnetic theory, if a charged particle is accelerated around another charged particle, that is nucleus, then there would be a continuous radiation of energy. This loss of energy would slow down the speed of electron and eventually the electron would fall into the nucleus. But such a collapse does not occur. Rutherford's model could not explain the theory. Here we can see this also. So this is nucleus, and around this nucleus there are electrons revolving. Now suppose this is electron revolving in this circular path. Now we know that electrons have negative charge, and in the center there is positively charged nucleus. So whenever charged particles moves around another charged particle, then it loses its energy and ultimately it should fall down in the nucleus. But actually it does not happen. Atoms are stable. So what is the drawback in this atom was further recorded by Niels Bohr. So you can see here the Bohr's model of an atom. Rutherford's model of an atom was unable to explain certain observations with regard to the atom, that is, stability of atom and the occurrence of the atomic spectra. First one we have seen above, stability about atom. According to Rutherford, this electron should fall into the nucleus, but this is not true. So first one about stability and second one about the spectra. Both these statement was corrected by Bohr's model of an atom. Niels Bohr accepted Rutherford's idea that the positive charge and the most of the mass of atom is concentrated in the nucleus, with the electrons present at some distance away. According to Bohr's theory, electrons revolve around nucleus in well-defined orbits or shells, each shell having a definite amount of energy associated with the electron in it. Therefore, these shells are also called as energy levels. So, idea of energy level first of all come from Niels Bohr. So, you can see there are some energy levels in which electrons are revolving. This is a fixed bar in which a particular electron can revolve. It cannot go in another shell on its own. The energy associated with the electrons in an orbit increases as the radius of orbit increases. Therefore, shells are named as KLMN, starting from the one closest to the nucleus. There are 4 shells, K, L, M and N. The K shell is nearest to nucleus, L is farther from nucleus, then M, and the farthest from nucleus is N shell. Now as you go from K to N, the energy of electron increases. So we can see there are some electrons which are revolving around nucleus in K orbit have fixed energy. The electrons which are revolving around nucleus in L shell have fixed energy, and so on. So every electron which is revolving around nucleus in a particular shell have a particular type of energy. Now third one is an electron in a shell can move to a higher or lower energy shell by absorbing or releasing a fixed amount of energy. So third one is that excitement of electron. We can here see in detail. You can see here structure of atom like that. These are shells around where nucleus are revolving. Now you can see this is K, this is L, this is M, and we can also draw a shell N. Now suppose if electrons is revolving around nucleus in the K shell. Now if electron revolve around this K shell only, then it will not lose its energy. If electrons is revolving around only L shell, it will not lose its energy while revolving. Why this is so? Because electrons forms a stationary waves. Due to these stationary waves, there is no loss of energy. If electrons loses energy, there are two conditions. Suppose one electron revolving in L shell and one is revolving in K shell. Now if electron from K shell want to jump to M shell, then it requires some energy. If you want to go to L shell, it requires some energy. So there will be absorption of energy. Now if electron revolving in L shell want to come in K shell, so obviously it will loses the energy. Why this is so? Because a particular orbit have a particular energy associated with them. If an electron want to come in K shell, so it should be lose the energy which is extra. Means if K shell have 55 kilojoule energy, L shell have 65 kilojoule energy, M shell have 100 kilojoule energy, then if electron revolving around in L shell want to come in K shell, then it should have energy only 45 kilojoule and the extra energy will be loosed. It will be released. Now if electron revolving around L shell want to come into M shell, then obviously it should have 100 kilojoule energy. So it will absorb the energy from its surrounding, that is 35 kilojoule energy it will absorb. So release of energy and absorption energy can take place only when electron get transit. So transition of electron are accompanied by the absorption of energy or release of energy. When electron goes to higher shell, then it will absorb the energy, and when electron comes to lower shell, it will release the energy. Next, the amount of energy absorbed and emitted is given by the difference of energies associated with the two energy level. Here we can see here also the energy absorbed equal to denoted by delta E, which will be E2 minus E1. That is also equal to h nu. Here h is Planck constant, whose value is 6.62 into 10 to the power minus 34 joule second, and nu is the frequency of radiation. Now here E2 and E1 denotes the energy of a particular orbit. Suppose electron want to jump from K to L shell, then L will be final shell. The energy of L will be denoted by E2 and the energy of K will be denoted by E1. So difference between these two energy level should have absorbed by the electron to go to higher energy level. Next, atomic structure. An atom consists of two parts, nucleus and extranuclear region. The nucleus is situated in the center of atom, and all the protons and neutrons are situated in nucleus. So we can see nucleus have protons and neutrons, and number of protons and neutrons is collectively known as nucleons. The entire mass of atom is almost concentrated in the nucleus. The overall charge nucleus is positive due to presence of positively charged protons, and neutrons are chargeless particles. The protons and neutrons are collectively known as nucleons, and the radius of nucleus of an atom is the order of 10 to the power minus 15 meter. If you talk about extranuclear region, there are some shells in which electrons are revolving. These orbits are called as energy levels, and energy levels are designated as K, L, M, N. So this is about the atomic structure.